Hello, this video is a series of videos to help you prepare for your final exam for college algebra. All right, so this is going to cover the first 10 questions on your review. It says solve the equation by using the square root property. All right, so I'm going to use the square root property, but before I can just go crazy and start taking square roots, I have to remember it needs to be isolated first. So since this is 3y squared is equal to negative 120, and really it's 3 times y squared is equal to negative 120. The first thing I want to do is divide both sides by 3, and then I get y squared equals negative 120 divided by 3 is negative 40. Okay, now I have it isolated. Now I can actually use the square root property, right? So to undo y squared, I simply take the square root of both sides. I don't want to forget the plus or minus. And so when I do the square root of y squared, I just get y. And then I have plus or minus the square root of negative 40. However, I can't leave it like this for a few reasons. First, we shouldn't have a negative inside of the square root. Remember that there is a property that says if you have the square root of negative 1, that is equal to I, which is the imaginary unit. So I'm actually going to take an I out. But even then, I can simplify 40. There is a perfect square inside of 40. So when I think about what times what equals 40, what comes to mind is 4 times 10. And that is a perfect square, right? 4 is 2 times 2. And then 10 would simplify to 2 times 5. But my perfect square is actually 4. And that means I can go ahead and take the square root of 4, which is 2, right? And then I would just have plus or minus 2i square root of 10. Now, if you want, you could also use the prime factorization to look for that perfect square as well. And I would have a group of 2, since it's the square root, a 2 would come out. And then I would have a 10 left over. So however you like to think of it. Notice this is 2 answers. This is 2i square root of 10 and also negative 2i square root of 10. Let's move along to number 2. Number 2 says solve the equation by using the quadratic formula. Really, I think it should just say solve the equation. Because right away, even though it says to use the quadratic formula, and you sure can, I would probably factor this because they all have a 3 in common. So I'm actually going to show you both ways. All right, so if I factor, I can take out the GCF, greatest common factor, which is 3, and I'd be left with x squared plus x minus 20 equals 0. And then I would just be looking for 2 numbers that add to get the middle term, that multiply to get negative 20. All right, and my hope would be that eventually I would come up with positive 5 and negative 4. That adds to get 1 and multiplies to get negative 20. Then I use zero product property and I set each piece equal to 0. And I end up with negative 5 and positive 4. And so that would be my solution set. Okay, so that's my factoring. Now it does say to use the quadratic formula, so let me show you what that would look like as well, to show you we would get the same answer regardless. All right, so the quadratic formula, if you recall, it's a special formula in math, and it is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a, where a, b, and c come from our coefficients from our quadratic. So the a is the number in front of x squared, the b is the number in front of x, and c is that last number, right? So I could label this as a is 3, b is 3, and c is negative 60. And all I do is plug those values in to my formula. So here's kind of what the quadratic formula looks like as a skeleton without anything plugged in. And now I'm just going to take those values and I'm going to plug them in. All right, so I'm going to have negative b, right? So 3 goes there. And then I have b squared right here. So I put a 3 there. And then for a is going to be a 3 as well. And a, you can see, is in 2 spots, right? It's in those 2 spots. and then c is negative 60. Okay, from this point, what I would probably do if I was doing this problem is I would go ahead and figure out, okay, what is this special number in here? It's actually called the discriminant, because it's going to kind of tell me like what type of answer I'm going to have. So I need to figure out what that part is first. So I would use my calculator to figure out that special number. So I end up with 729 for just that inside part. So I'm going to clean this up a little bit. This is going to become negative 3 plus or minus the square root of 729 over 2 times 3, which is 6. Okay, now I will use my calculator to evaluate the square root of 729. My hope is that it is a perfect square, which I know it should be, honestly, by looking at my different answer choices. Okay, so that's great. And I also already know what the answer is. But anyways, I do the square root of 729, and I'm very happy to see that it is a perfect square. It is 27. So since this whole thing is 27, I end up with negative 3 plus or minus this, 27 over 6. Notice the square root goes away because I have a perfect square, and the square root of 729 is 27. Okay, now I can break this apart as negative 3 plus 27 over 6, comma, negative 3 minus 27 over 6. And then I just need to do some arithmetic. All right, and I can use a calculator if I want, but I'm going to show you what this would look like by hand. So negative 3 plus 27 is positive 24 divided by 6. Negative 3 minus 27 would be negative 30 divided by 6. Now you can see we're really close to finally getting our answer, right? 24 divided by 6 is 4. Negative 30 divided by 6 is negative 5. So you can see either way, we end up with negative 5 comma 4 or 4 comma negative 5, which is right here. All right, let's move on to number 3. It says simplify the radical equation if possible. So this one is one that looks scary, but it's really not that bad because we just have the fifth root on both sides of our equation. So we can actually just raise both sides to the fifth power, and we end up with 10z plus 7 is equal to 7z plus 16. And then you can see it's turned into a linear equation. So I just want to get my z's on one side of the equal sign. So I'd probably subtract 7z first. And then I would get 3z plus 7 equals 16. And then I would subtract 7 from both sides, which would give me 9. So 3z is equal to 9. Divide both sides by 3. 9 divided by 3 is 3. So my solution set is 3. And you know what's cool is I could plug this back in to check it, right? So if I plug it back in to check it, it'll be 10 times 3 plus 7 on the left side, and on the right side we'll have the fifth root of 7 times 3 plus 16. Okay, so this is a good way to check it. So right here would become 37, so the fifth root of 37, and over here 7 times 3 is 21 plus 16 is also 37. So you can see we get equivalent expressions. Yay! Okay, let's try number 4. Okay, so for number 4, we're solving a higher level polynomial, and I see that we have the fourth power. And so what I want to do is I want to factor this. But I'm going to keep in mind that when I'm factoring, because this is x to the fourth, I'm going to have x squared and x squared. And then I want to figure out two numbers that add to get negative 18 that multiply to get 32. So off to the side, I would try to figure out what those two numbers are. So it might take a little bit, but I think it's going to be negative 16 and negative 2, right? Because that will add to give me negative 18. When I multiply, I get positive 32. So I would write it like this. And then I can use the zero product property, which just says to set both pieces equal to 0 to finish solving. So then I would add 16 to both sides. And I get x squared equals 16. I take the square root. I don't forget the plus or minus. And the square root of 16 is 4. So I get plus or minus 4. Over here, I would add 2 to both sides. Take the square root of both sides, and I get plus or minus the square root of 2, which is this answer. Okay, let's try number 5. All right, number 5 says determine the domain and range of the function. All right, so just a reminder, domain, when we're looking visually, since the domain are our x values, we're going to go from left to right? So if you think about this graph, it doesn't just go this way, it actually goes this way with arrows, like forever. So how far left is that? So on my x-axis, it's going to eventually, this arrow goes all the way this way to negative infinity, which is why I would start my domain at negative infinity. And then it's going to eventually, this arrow is going to go all the way to 10, 100, 1,000, all the way to positive infinity. This graph keeps going like that, all the way down, right? So it would be from negative infinity to positive infinity for my domain. For my range, it is bottom to top, since we're talking about the y values, right? And so if you look at our y-axis, which is this, right? It goes on forever. This graph, and I know they didn't draw arrows, but we know there's arrows. This graph goes all the way down, which means this lowest part right here is at negative infinity. And remember, infinities never get brackets, but it goes all the way up. So where does it stop? What's the highest point on the graph? That's -2. -2 gets a bracket because there's not a hole in the graph. It is part of the graph itself. All right. The way it wouldn't be a bracket is if that same graph looked like this and it had like a hole there. Okay, but that did not happen. It's definitely get a bracket. All right, so that one would be this one, the first one. All right, let's try number 6. This is just function notation. So it says use the graph to answer the following question. And it says determine f at -2. So f at -2 is referring to when, so we know it's usually f of x, right? So when x is -2, what is our y value? Okay, that's what it says in simpler terms. So when x is -2, our y value is actually at 0. So f at -2 is equal to 0. All right, so number 7 says